It's just a sheet of very thin, flexible film, and then we lay Technora fibres. So we use 1000 denier Technora, which is all the black stuff through here, and we align that exactly along the load lines in the sail. So the primary loads in a sail are the obvious ones. When you downhaul a sail, you can feel all the tension that you're putting into a sail. So this is the primary load, and this is something that's biased towards the luff edge. So we put a lot of Technora fibre down the luff edge to transfer those high loads back into the sail. So the diagram up here shows the fibre concentration. It's highest in the tack and the head of the sail, and along the luff edge of the sail to really transfer those high downhaul loads. The secondary loads in the sail, another obvious one, you outhaul the sail and there's a lot of tension that radiates out of the clew. So the secondary load paths are all focused on that clew, and they radiate throughout the sail. The tertiary load paths are in the foot of the sail. So this is probably the high load section of the sail where there's a lot of impact, and there's also a lot of force coming out of the tack and the clew, so it's a bit more fibre to transfer loads in that section. Perimeter loads, a lot of this is to reinforce the perimeter, make sure that there's no stretch along the perimeter, so the design shape of the sail is retained for as long as possible. Batten tension. So there's a lot of tension running along these exact paths here, so it's very simple to align fibre exactly along those load paths to minimise any long-term stretch on the batten pockets. And then we also have a little bit of shear in sails, so we can really control the way that the sail flexes, and by putting the right amount of fibre in here, we can get something that works like a spring. So we can control how fast that leech and upper head will react and spring back on itself. And so this is something that will be really interesting in years to come, is using fibre to create spring-like effects throughout the sail. And this is really put to a lot of effect. In the blade, we have a little less tension in the upper leech, so it's not as obvious as when we look at the next sail. On the S1 Pro, we really use these diagonal fibres to really control the spring and characteristics that we use there. The last thing that we put across the sail is a ripstop. So we use an aramid, which is like Kevlar. Kevlar is like a gold-coloured fibre. This is something that's really strong and allows us to really put a strong ripstop effect on the sail. So we use like an 1100 denier Kevlar, so it's quite a substantial fibre. And there's an X-ply over the entire membrane of our blade sail. So our blade is something that's wins a lot of sail tests. We're getting a lot of positive feedback from anyone that ever uses the blade. It's something that was already quite a benchmark product. The Blade Pro, we really lift that up again. So we might get Scott McKercher up here to say a couple of quick words. Scott was instrumental in developing the blade from the start, and so this was something that was going to be very interesting for him to play with.
Yes, one of the fortunate few to have tried this sail. Ben put it into my hands in Margaret River on a nice southwest day, and when you first pick it up, it's obvious, it's light. You rig it up, you pump on the beach, it's like you can feel on the beach there's an extra amount of response or reflex to the sail as to what the amount of brain muscle memory I've already had with using the blade a lot in the past. It was different. But then I got on the water. It was probably a 4 to 5 foot day, kind of light marginal winds, and it was just cherry from the first bottom turn to the first reaction with the lip. It was just such an instantaneous response. Like when you hit the lip, the reaction through the leech, through the whole sail, is just so much clearly more defined than what I was previously used to. So, you know, I don't understand any of the things that Ben talks about, but I just know that it feels really good.
A lot of the spider fibre technology to reinforce the clue area and have a very small, lightweight clue section and transfer that load through the window. So the blade has quite a large window. It allows the guys to be able to see the lip and position themselves correctly, and this spider fibre technology means that it's also really strong. New way of putting the battens into the sail. So instead of having a batten pocket that's sewn onto the outside of the sail, the battens are built into the seam, so the sail is a lot more symmetrical. As one panel overlaps the next panel, and the batten is placed through the middle. And the important thing with the way we do this is it allows us to develop a new way of tensioning the batten. Sails have always had a batten tensioner that's applied to one side of the sail or the other, so this allows us to run the tensions from both skins. So that's really quite critical to making something that's a lot more symmetrical than any of the batten pocket constructions we've used in the past. And this is something that we'll get back to later on some of the other models as well.